Hi guys, how are you doing? I'm Mohammad Sadri, postdoctoral researcher at Electrical Engineering Department of TU Kaiserslautern. This video is not part of the Zinc lessons that I'm creating, and it is actually a very simple topic. It is about installing xilinx toolset, more specifically the vivado toolset on your Linux platform. And I'm creating this because I have seen a lot of guys, they are still using Windows for their project. And actually I'm not saying that Windows is bad, but maybe for some serious projects Linux can be better. So since I have been asked about how to install this thing on Linux by people who actually they don't know Linux at all, it's their first time they are using Linux, and it's kind of frustrating for them to install the tool on Linux. I'm going to do the whole process for you so that you can see how it is done. Actually, if you have been using Linux for some while, that is very easy to you, but if you are really newbie to Linux, then it can be a problem. So why am I or most of the developers using Linux for their projects actually as the development platform? Maybe the first reason is it's free, it's open source, and these things like that. And actually I believe these are not really important because almost everybody has access to the Windows operating system. On every notebook that you buy there is a pre-installed version of Windows. So actually this is not really a reason why Linux is preferred over Windows. Maybe since it is open source, it's better because you have access to the source code of every single program which is executed on your system. But usually it needs a high level of expertise, in fact, to customize that code. So, and the xilinx toolset, when you install it on Linux, obviously that's not open source. You cannot change anything there. So, but in any case, the Linux brings you a kind of very robust environment for your design and development project. So personally, I have been using Linux for more than 10 years, and I have found it very robust, a platform that is really under my hands. I can do whatever I like. It is under my control. It's not making decision of its own, I can say. It's something that you can rely on, and in Windows, honestly speaking, I don't see this. Furthermore, you find a large number of applications and utilities that you can use for code and project management. So you can have different types of repositories for your code, and then you can collaborate with other people for development tasks, and the Linux platform really allows you to do that very easily and in a robust manner. So it's a really good platform for development. And more than that, there are a lot of, in fact, automation that you can do inside Linux using your scripts. And this includes also document creation and document management. So instead of using, in fact, the tools like Microsoft Word for generating your reports, you can, for example, use LaTeX and or any text-based system, and then you can have a kind of automated document generation system, which can be integrated, in fact, into your code, kind of. So as you develop, as you code, as you create your hardware and you develop your software and hardware at the same time, your document can be created. And this is something really useful. I have found LaTeX and text-based, in fact, document creation very useful, and I really like it more than the Word and any kind of, in fact, document generation process like that, in which you directly go and write the document. When you in fact use latex or text, you are basically creating a main text file which then will be compiled into the PDF, and there are commands with which you can control the flow of how the final document is going to look like. And this is something really interesting. It's kind of program that you are writing to create the final document, and it's really useful. So for task automation, you can have a lot of Python scripts, for example, different types of script, TCL, Python, and these things, and with them you can really automate a large number of, in fact, regular tasks that you need to do during your development flow. So the Linux platform is really allowing you to do all of these very easily, and I don't say they are not possible under Windows. They are definitely possible under Windows, but I think Linux is natively created. It has native support for this set of tools, and I have found it much more convenient to use Linux for this type of, in fact, tasks compared to Windows. There's another important thing, and that is most of the embedded systems that you see in today's world, they are basically using Linux. So the Linux is running there, and one very clear example is most of your mobile phones. So whatever smartphone you have, if it is not running the embedded Windows, is running practically Linux, and then the Android on the top of Linux is coming up on your system and is running. So the Linux is there on your embedded system, and obviously in order to develop applications for this kind of Linux embedded systems, the best platform will be obviously Linux. So if I have an x86, in fact, computer, a notebook, a desktop, and I'm using that for application development for my mobile phone, for application development for different types of embedded systems, for application development, in fact, for microblaze core, or on my ARM host on the Zinc, if I'm doing this task, obviously the best platform on which I can do this task is the Linux itself, because basically I am running the Linux on my target embedded system. So there's a kind of match between the development platform, the platform on which you are creating the executable, and then the target platform, the platform on which you are executing the created executable. So due to these reasons and many other reasons, I practically use Linux for every FPGA project that I do, and I have found people seeking for moving from Windows to Linux, and I think it's a kind of good decision. So what I'm going to show you in this video is that if we go very fast through the entire flow, download, install, license management, keyboard driver installation, running different tools for vivado, xilinx vivado, and I will suppose that you don't know anything about Linux, so I talk about every basic, in fact, option and command that you should issue. And I have found people, when they begin using Linux, one very important problem is usually permissions. And for example, you want to install the Xilinx toolset as root, and then you want to use it as a normal user. And usually people get confused in this step, so I will try to cover these permissions in more detail. So here, I think I come to the Xilinx website, and then support, and then downloads, and then we have, in fact, Vivado design tool, ISE design tools. These are all Vivado design tools. The latest one at the time of recording this video is 2014.3, and here you have some quick links, and you, in fact, click on your on the Linux 64-bit web install client, which is actually 72 megabytes, and this is a kind of executable that I download and I run on my system, and then I select which parts of the main Vivado tool I want to locally install on my system, and which of available target devices I want to have on my system. For example, Zinc, Kintex, Virtex 7, what type of target, in fact, FPGA I want to begin development for. And So instead of directly downloading, in fact, the very big 7.25 gigabytes tool, which is actually containing everything, you download this 72 megabytes web install application, and then you use it, and you selectively download and install only and only those portions of the program that you really need and you really use. And then later, if you needed any other, in fact, target FPGA, then you can come, there are some menus in the tool that you can go there and you can run this web install again, and you can, in fact, install those specific. So I click here, you log in with your username password, and if you don't have, you create one username password, create account here, and then you install the 72 megabytes file. So I pause the video, I do this, and I come back to you. Okay, now I have downloaded the file and it's here, and actually it is a file 76 megabytes, and now I'm going to, in fact, run this file. One important thing is that the platform on which I'm installing this thing and I'm showing to you this thing is Ubuntu 12.04.5 LTS, and this platform, I'm pretty sure that the tool runs on the platform fine and there's no problem with any, in fact, functionality of the tool. So I have been using for I would say 1 year and everything is fine. So if you want to begin from a very, in fact, you want to be confident that your Linux is supporting every available option in Vivado, then maybe this platform is a nice one. Okay, so I'm on my command prompt and I want to run that web install application. And what I do, in fact, I go to the folder that I have downloaded this guy inside that folder. So what was the folder name? It's /home/ in fact, it's my local home, and then /downloads and xilinx web install. This is the folder in which I have, in fact, stored that file. So it will be, I am in my home. Whenever you type cd, you are in your home, and then downloads, I go to the downloads folder, and then I go to the xilinx web install folder, and I have my file here. ls-l will list the files available in the folder, and this is the file. And actually I want to run this file, but the problem is, if you want to run this file, this file should have the execute permission. So the first thing you do, you give the file execute permission. So chmod +x and then the file name. Okay, chmod. Okay, now if I say ls-l again, then I have the file here. It's shown in green, and in the list of permissions of that file I see that the file has execute permission. Okay, so after you issue the chmod command and then you have the executable version of the file, one important point is that whenever you want to, in fact, run that executable, instead of running the executable as a normal user, it's better to run that executable in super user mode. So here what I have done, I have tried to run that executable in normal user mode. It's not really a problem, you can do that, but then whenever you run it with your normal user, in fact, you will have access only and only to your own home folder, and you should install the tool inside your own home folder. And I don't like, in fact, to do that. It's not a standard method of installing, in fact, xilinx vivado. So what I do, I have this executable, it's my web install application, and I run it in super user mode. So I say sudo and then the name of the tool, and now I just enter my super user password, and then the tool gets executed. Okay, I have the window here, and it's a list of, in fact, supported platforms. It says, for example, I'm supporting Ubuntu 14.4 LTS. Maybe you want to use this one instead of 12.4. And here is the section that you enter your xilinx account, in fact, information. So these are required because now the web install application is going to fetch everything out of xilinx website. So I in fact add these fields and I come back to you. Okay, then after you entered your username and password, you reach in fact this dialog box here, which is terms of use and in fact conditions that I think you are agree with all of them. And then is a very important dialog box in which you select which type of installation you want to have. So there are different versions of Vivado can be installed on your tool, and usually either you will select Vivado System Edition or you will select Vivado Design Edition. For most of the boards which are being sold in the market as evaluation kits, the license which comes along with the board is Vivado Design Edition. And then Vivado System Edition contains also the Xilinx, in fact, system generator toolset, and it contains Xilinx Vivado HLS, which they in fact need different licenses. So if you have purchased the license, then you select Vivado System Edition, and then you come to the next dialog box in which you select which parts of the design tool should be installed, and then which devices you want to have on your hard drive. The files for which devices should be copied to your hard drive directly. So here we have Vivado Design Suite, and usually I select Software Development Kit also to be installed. And this is because Software Development Kit is a really important piece of software. Whenever you have any CPU in your design, for example microblades, or you have the ARM cores of the Zinc device, whenever you have any of these guys in your design, you want to create a program for that, and as soon as you want to compile that program, then you will definitely need the Software Development Kit. Either you are creating a bare metal application for that CPU, or you are creating a Linux based application for that CPU. It's a very good idea to have the Software Development Kit installed on the system, because along with the Software Development Kit, the ARM toolchain and the microblades toolchain, the ARM cross compiler and the microblades cross compiler will also be installed, and you need them even if you are developing in fact Linux based application and you are running Linux on your microblades or ARM CPU core. Then for the devices, you can select whatever device that you use in your project, or you can keep all of them selected. But if for example you don't use any ultra scale device in your project and you don't have any plan to do that, you can just save some space by in fact disabling this option. Then one very important point that I always enable is install cable drivers. So to be able to install cable drivers successfully, it's very important that you run the tool as super user. As I showed you, you use the sudo command to run the tool. So I'm now running the web install tool of Xilinx as super user, and now I have enabled install cable drivers, and I'm asking the web install to also install the cable drivers so that later my computer can recognize the JTAG cable easily and without any problem. Okay, so I freed some space on my hard drive, and then I keep in fact these options enabled, and in series 7 maybe I keep Vertex 7 and Kintex 7 and then the Zinc device enabled, and I have again install cable drivers, they are all enabled. And I come back into this dialog box here, and the standard place on which you install the tool is /opt/Xilinx, and what will happen is that the installer will create the vivado folder, vivado underline HLS folder, and the SDK folder, and inside each of these folders it will create another subfolder with the version of the tool that you are installing. So very easily you can have different versions of vivado tool from different years, different times, all together in your system, because it may happen that you need an older version during one project and you have to use the newer version in another project. And it has happened sometimes that, for example, you are using a piece of IP and xilinx upgrades in fact vivado tool, and exactly that piece of IP in the next version of the tool has a kind of problem. For example, there was this PCI Express AXI bridge. It was working in 2013.4 I think, or 0.3, but it was not working in 2014.2, and now it is again working in 2014.3. so these are these set of IP blocks. So this is why you may like to have several versions of vivado installed on your machine all together. Anyway, these are some reports: download size, disk space required, disk space available, and create program. This is not important for Linux. This is the only important point. And don't forget, we are running the in fact installer as the root, and I say next, and then I say install, and then I wait maybe half an hour for the download to complete and for the install to complete. I pause creating the video, and then I come back to you again. Okay, now I have in fact all of the files copied to my hard drive, and it says that installation is completed successfully. When it says so, it means the installation is done completely, but well, you can always double check. So anyway, we say okay, and we suppose that everything is fine. Now we are here in the dialog box of vivado license manager, and actually here you can start a trial license, get a free license, start a 30-day evaluation, or you have already purchased a license previously and you can in fact get your license. The point is that what I do, I just close this window. This window is not important at all, and I will show you what you should do with your license that you have received from Xilinx or any other source. So as you get your board, you buy your board, you get your voucher, and then you go to Xilinx website, and then you do that procedure, and then the Xilinx gives you the license file. Or for example, your system administrator gives you the license file, or I don't know, there's a license file for all of the students in the university that you can use. Then you get that file, that text file, and I show you in fact what you should do with that text file. So what I do here, just close this window. It's not important. Yes, I close this window, and my installation is over. Now if I look where the files are located, in fact the files are located inside /opt folder, /opt/Xilinx. I go to this folder, I say ls, and then now I have vivado, HLS, and SDK. And what I have here is an old version of ISE I use sometimes for Series 6 devices, but for Series 7 I don't use ISE, I use vivado or vivado HLS SDK. And HLS I don't use here on this system, I don't have the license, but for vivado I have a kind of license for the Z board. So this is the installation, is complete, and now if I say ls-l here, what I see is that the owner of all of these folders is root, and this is something correct. It should be like this. This means that only root can change these files, can change something inside here, and this is acceptable to me. I don't want normal users to be able to change the contents of these folders. I want only root to be able to change the content of this folder. But the point is that now I want to in fact run vivado for the first time, and what I do, I come to my own home folder. So I say cd, and then I need a small script to be executed. So I say source the script that is actually it's located in the xilinx vivado folder, and the version of vivado that I have installed, and it's called setting64. So what you do in Ubuntu, you issue this command, and as you issue this command, you are now sure that if you type vivado, the Linux recognizes where this executable is located and executes this executable. So in fact, this file contains all of the definitions and the configuration that you need to do before you can either run vivado or software development kit or xmd or vivado hls, any of these tools. So this is a very important step whenever you want to run vivado. And now I can issue the vivado command. Okay, so I cleared my screen. I say vivado, and let's see what happens. I'm in my own home folder. So pwd, I am in my own home folder. I say vivado. We have just installed vivado. I press enter. Let's see what happens. Okay, so basically this is what happens. You have the vivado environment, and you have these kind of small messages here, and I think the environment is operational and you can use it. So you go ahead and you create probably your first project, not important which device I'm selecting for now. Okay, this is fine, but there's one point that I have seen sometimes is happening, and that is when you in fact run vivado, a folder gets created inside your home folder, and that folder is called .xilinx. Okay, so this .xilinx folder gets created inside your home folder, and sometimes I have seen that the permission of this .xilinx folder is not correct, and when you try to run vivado, you encounter a load of, in fact, warning and error messages. If that happened to you, what you need to do is to change the permission, the ownership of this folder. The owner of .xilinx folder, which is located in fact inside your own home folder in Linux, the owner of this guy is yourself. Okay, the owner is not the root. So if the owner is right now the root, you should change it. And how do I do that? How do I change that? It's very easy. I use the chown command, chown -r, and then with this command you change the ownership of that folder, the name of the owner, the name of the group that the owner belongs to, and then .xilinx, and you press enter. Okay, and now this command is this command was practically useless. You should run this command with sudo. So you say sudo, and then you enter your in fact root password, and now the ownership of the folder is changed. Also, the ownership of all of the files inside that folder is changed. So for 2014.3 I didn't see this problem, but if it happened, you can solve the problem using this command. Now suppose that I have a license file and I want to install the license file. So suppose that this is my license file. You have received your license file. Suppose that this is the license file. Okay, the license file is basically a text file, and it is called, for example, my license the dat. Suppose that you have received this file from Xilinx. Okay, so you have received this file from Xilinx, and this is your license. So my license.dat. This is my license. And what should I do with the license? All you need to do is just to copy my license to .xilinx folder. Okay, and that is it. So whenever you go to .xilinx folder, you should see your license file, and as you issue in fact the vivado, and then you create your design and you begin synthesis. At the time of synthesis, it checks your license, and actually this is the location that vivado looks at to see if your license is there or not. So you don't need to set any environment variable, and that should work. But if it didn't work, there's one more thing that you can do, and that is to set an environment variable to make sure that the Xilinx toolset sees your license file. So the environment variable that you can set is lm license file. So I say export lm license file is equal to /home/sadri, and this sadri will be replaced by your own in fact username, and then .xilinx, and then the name of the license file, so my license.dat. Now if I look at this environment variable that I set right now, lm license file, I can see that this environment variable is set to this value. And now as I run the vivado tool, in fact either it will look at the .xilinx folder itself and it will find the Xilinx file, or if it didn't, one thing that vivado will do will look at this environment variable. And since you have set the environment variable correctly, the Xilinx tool should see your license and should. So there should not be any specific problem with the license. If you had problem, it means either your date in your computer is not correct, or your license is not valid. For example, your license is for an older version of vivado, or there's a mismatch, maybe your host ID is not correct. So whenever in fact you want to tell Xilinx to produce a license for you, you give Xilinx your host ID. And how do you obtain your host ID inside Linux is actually very easy. You can use always the ifconfig command. Okay, now we reach the final point of this talk, in which I want to show you how different tools are in fact executed from the command line. The vivado itself, you just, after you sourced the settings file, after you did this step, and if you do this step once in the beginning, it's enough. So whenever you open one of these command shells in which you enter commands for each in fact command shell, for each command environment, you should in fact source this file once, and that is enough. And now in order to run vivado, you can just issue the vivado command. In order to run the SDK, you can run xSDK. In order to run xmd, you can issue xmd. And so you have access to all of these tools directly from your command line. Okay, now I want to test if xmd can recognize the programming cable. And I have not done anything. I have just installed vivado 2014.3, and then I have sourced the settings 64.sh file, and also during installation I told the tool to install cable drivers. So myself, I didn't do anything explicit regarding the cable drivers. And let's see if xmd recognizes the board. My Z board is now turned on, it's connected to my computer, and I now run xmd, and just I would say connect ARM hardware. Now connect ARM hardware. Yeah, so it is working, and I personally think that you don't need to do anything special for having the JTAG cable being recognized by your Linux system. from this version of Vivado. Previous versions you had to install something yourself, but now there is no more needed. Really, the installation tool of Xilinx performs all of the task for you completely. Finally, if you have your board, for example your Z board, and you want to have a kind of serial console, then you can use either Minicom or Picocom. Okay, but the point here is that when you want to run the Minicom or Picocom, you need in fact to run them with super user. So suppose that I have my Z board connected to one of the USB ports of my laptop. I have its UART port connected to USB port of my laptop, and I want to run Picocom to have the serial console, and then to run something on my ARM host and to see if it's working or not. How do I issue Picocom? Okay, using Picocom. In order to use Picocom or Minicom to have the serial console, you need to run them with super user mode. So all either Minicom or Picocom should be run with sudo command. For example, sudo picocom -h. Here are the options for Picocom, and in fact Picocom options, and then tty device, and you have connected the UART port of your Z board to your PC, in fact through USB. And as you make this connection to your PC, then there are a set of messages created by the Linux kernel, and these messages, they tell you in fact on which device the connection is made. So if I run the dmess command, this is the log which is produced by the Linux kernel, and if I look at the end of the log, I see the name of the device on which my Z board is connected to my notebook. So when I issue the Picocom command, for example, I say sudo picocom --baud rate 115.200 flow control no --parity. I think we don't have any parity, and then the name of the device. For the name of the device, I say TTY-ACM 0, and now in fact I'm connected to through this to the UART port of the Z board. And as you run something on your ARM host, the messages which are copied to the UART will appear here. That is it for now, and this is the end of this video. I think you have now your Vivado toolset on your Linux. You can program your board using it, you can debug your board, you can run Vivado, software development kit, XSDK, and you can see the outputs of UART of your board. There are a lot of other things that you might like to learn about Linux, but I think these are the basics that make you begin your project inside Linux, and as it goes you can learn more about the Linux system. The Google or any other search engine is there, you can use it and learn more. Okay, thanks for watching, bye.